Today we are going to demonstrate to you an experiment that changed our world by solving the mystery of light. Light was always a very strange, bizarre and vexing thing, and physicists were never on the same page regarding the characteristics of light. Young double-slit experiment just proved that light was a wave, but the experiment shattered that assumption completely. What we observed was that when we bombarded photons of light, electrons were emitted, which gave rise to photoelectric current. When a photon is bombarded, it transfers its kinetic energy to the electron, and if that exceeds a certain value, electrons are emitted. But how does this prove light is a particle and not a wave in this situation? Well, wave transfer its energy continuously, so if the light was a wave, we would observe the electron to be emitted at all frequencies of light. But our observations totally contradict that. It is all or nothing principle. If the frequency is above the threshold frequency, we see that a current is emitted, but if it is just below that, we see nothing. There is no photocurrent at all. So when I will shine the mobile light, there will be no current because it is below the threshold frequency, but when I will shine the light of tungsten filament, there will be definite current. And another thing is that as I increase the intensity of light by reducing the distance, the photocurrent will increase. As more the number of photons are bombarded, more the electron will be ejected, and hence the current will be increased.
Let's have a look at the experimental apparatus. Here we have metal wire and it is connected with a sensitive galvanometer, and we have two light sources. One is mobile flashlight and other is tungsten filament. Let's see what happens if we shine the mobile flashlight on the surface of the metal, and you can see here is the no deflection in the sensitive galvanometer. Now turn on the bulb and close the box and decrease the distance. As well as we decrease the distance, the intensity of light increases and the deflection in the galvanometer also increases, and you can see in order to extrapolate relationship between intensity of light and photocurrent, it is necessary to draw a graph between current and intensity. I have taken some reading and plotted the graph. It looked somewhat like this. Thus, it is proven that as we increase intensity of light, photocurrent also increases.
This phenomenal experiment led to wave-particle duality of light, which was to change our world. It improved our understanding of quantum world and the bizarreness of light. As simple as it may seem, it took Einstein decades to interpret this experiment, which won Albert Einstein the Nobel Prize in 1921.